Hey guys, welcome to Coding Wizards. My name is Akash Verma and we will learn in this video we will learn about custom state management solution. So in previous video we have talked about API integration, how to implement APIs in Flutter app. So we have talked about different ways how we can implement APIs in the Flutter app. So in this video we will overcome a challenge that we faced in the previous video, that in the controller, the normal class that we have used for the controller, we didn't have onReady and onInit method. Also the most important is onDispose, because once we create the value notifiers we must dispose them. So for that we have designed, like I have designed something like GetX library where we get the controllers. So I have created my own controller, we have named it BaseController, and we have on inside that we have these three functions for onInit whenever controller is created, then onReady whenever the wherever we inject it, the first frame is rendered, this onReady will be called. Then we have onDispose whenever the route is disposed for that screen. So this is the basic idea about having a base controller, so that we can call APIs, we can do things like dispose the resources that are not being used. So whenever we close the screen we dispose the resources for that screen. So we will see how we can create our own lightweight library for dependency injection and state management. So in this video our focus will be on dependency injection plus how to properly integrate API and folder structure. So these are the three things that we will cover in this video. So let's start with the main dot. So here things are same as we get by default. So title, theme, then about. This is the new thing. We have a navigator observer. So this is navigator observers are like whenever we push a new route or open a new screen or close a screen, we want to detect that change globally. For that we can add a observer here. So we can pass multiple observers here. So whenever new route is pushed, this class will be triggered. So inside that we have extended route observer. Let's close this. So route observer, so it will observe all the events for the navigation, like push, pop, remove, replace, all the things. So here we have route observer, we need to give it like we have given that it will observe on the page route. So this is the idea behind this. So whenever we push some new routes, this thing here, it accepts a list of navigator observer. So here respected methods will be called. So whenever we push new route, this will be called. Whenever a route is closed, this will be called. Whenever route is removed, this will be called. And whenever we use navigator dot push replacement, this will be called. So this is the idea. So in this we have another thing in the dependency injection, which is controller store, that we are storing all the dependencies somewhere. So this is the store for the controller. It is like get.put and get.find kind of thing. So I have created my own lightweight library for that purpose. Just why I am teaching all these things, just because you get the better understanding how these libraries are working internally. Because whenever there is an interview, they ask a lot of understanding based questions, like how block is working, how GetX is working, how dependency injection works, or what is the dependency injection first of all. So these are the questions that you will be able to answer when you have understanding about these things, how GetX is handling the dependencies, how block is managing the state. So for that purpose only I am teaching all of these things, because whenever we create a new app or build a app in the Flutter, we are going to use a state management solution definitely. So there is no like workaround around that. So we need a state management solution, and for the understanding I have created something like GetX. So we can inject dependencies as well as manage the state throughout the app. So for that we need to understand these concepts, how GetX is managing all these things. So we have a controller store where like get.put, for that we have get.lazyPut, for we have our own lazyPut, we have our own find method, then we have dispose out, that will be called internally to fire the callback on these things like onInit, onReady. So first let's see. So this class, this file is like clear, there is not a lot of things in this, and I think navigator observers are also clear, because whenever interview ask a question about observers, navigator observers, you must explain that these are the things that will be fired or that will be used to detect the new route pushed or pop kind of things. So this is the these are the things for the navigator observers. Then let's start from here. So in this class, the route observer, it has did push, which is has been overridden from route observer. So if we go here, we have subscribe, unsubscribe, did push, these are the things. So these are the things. So here we are overriding only few, because in this example, in this video, we are going to use need only these are the things, these things. So here we have did push, whenever a new route is pushed, we get the route and previous route. So we have both the routes, the previous one and the new one. Previous might be null, because whenever there is only one route, so previous will be null. So here we are simply checking if route, the current route is name is not null, then we have set the current route in the controller store, that this is the current route which is being shown on the screen. Then we have did pause, did pop, same thing is here, the current route and the previous route. Here we are also checking if current the route is not null, then dispose that route, and because it is the current route that is being popped. So this is the screen that is being closed, and this is the screen that will be bring to front, brought to front. So the current route will be disposed, and the previous route will be the current route. So this is the check. If current route is not null, then dispose the current route. So and then previous route is not null, then set current route as a previous route. So this is the idea behind did pop. In did remove, we are doing the same thing, that if current route is not null, then dispose the current route and bring the last route to the front. So current route will be the last one. Did replace is like this is the new route and this is the old route. So we are disposing the old route and setting new route in the our controller store. So if we go inside the controller store, I think this is clear for now. If we go inside the controller store, in this we have two things, basically 1, 2 and 3, 4 things. So these are the two most important things, because these are the active controllers and these are the lazy factories. So in the GetX we have lazyPut and put, two things. So idea behind put and lazyPut is, whenever we put something, like we call get.put, it will create the controller immediately and return it. And whenever we use lazyPut, then whenever we call get.find, at that time it will create the controller. So in this example we are using lazyPut because it is more efficient than the put. So we don't have put here, we have only lazyPut. We can create put also in the similar fashion like lazyPut. So all the controllers that has been created will be stored inside this, and all the controllers that have been injected but not created because get.find has not been called on that factories, the builder method will be stored here. So here we have string and then map. So string is the route, map is like the type and the object itself. So we can inject multiple controllers on the same route, on the single route. That is why we have map as a second value here. So I think this is clear. So this will be the active controllers that are in the memory, and these are the factories that simply store the function to create the controller but has not been created because we haven't called the get.find for that controller. So then we have current route that we have seen in this, that we are setting the current route as this. So whatever value we will whatever route we will set from this screen, this observer, that will be set here. So we have keep like track of current route, which route is being displayed on the screen. Then we have route observer. Then here we have lazyPut for injecting the dependency. So first let's understand what is dependency injection. So suppose we have a class named car, then that car needs an object of engine class. So instead of manually let's understand it here. So let's see, we have a class named car that needs another class, let's engine, name it, then create a constructor, and inside that we have final engine, so this is the code. So whenever we want to create the object of car class, we have to pass the engine also. So let's see how we can create. So final car is equal to car. Now it needs a engine. So for that we must create a engine also. Engine is equal to engine. Then we will pass this inside here. So this is the okay, so this is, I think engine spelling incorrect, okay, ignore it. So whenever we need object of car class, we have to create this object also. And let's suppose that it has multiple things inside this, like engine 1, 2, 3, like different objects. Like it can have engine, it can have wheels, it can have mirror kind of things. So we have to create all the things before creating this car object. So for that the dependency injection helps in testing. Whenever we test our code, then we don't have to create all the objects just to create this car class. So we will define a way to inject the dependencies, and we will define how they will be injected and where they will be injected. So for that, if we use like GetX, so in that we can call get.put and we can somewhere globally we can put it like whenever you need engine, just call this. Then inside this class we can directly add here that get.find like this. So we don't have to pass it in the constructor. So this is how dependency injection works. So we don't have to pass this one, so we can directly create the class car object. So this is the dependency injection. So the basic idea behind having integrating dependency injection is it helps in unit testing, class testing, different kind of testing. Whenever we want to test this class, we don't have to pass all these things. We can centralize it somewhere in CI/CD pipeline, so that we don't have to ensure that all the objects are created whenever we just want to test this object. So this is the idea behind dependency injection, and it helps in managing the dependencies in the production and production code. It makes our code scalable also. So I think you have all understood the dependency injection. We will talk about dependency injection in detail in some other videos. In this video our focus will be on API integration, then state management, and the GetX, how we can create our own lightweight state management library. So here we have our BaseController and then controller store. So okay, so here we have lazyPut. Whenever we will put all the controllers before they will be used, so that with this function. So here we pass factory for creating the BaseController. So this is a function which returns the controller. So inside that we are checking the what is the current route, then route is not equals to null, then there is no route, and then this is the another code which is important. So here we are saying that whatever you have put here factory, just in the lazy factories that we have, it is static, so it will be only one object. It won't be created again and again whenever we create object of this class. So in the factories we are putting that factory inside that. So on the current route, so the key will be current route, then we are putting the empty factory. So here we are putting basically a empty map, a function which puts a empty map. So it is a little bit difficult to understand on the first instance. So you will get the basic idea about this. You don't have to memorize all these things, just have a basic understanding about how dependency injection is working inside the GetX or block, whatever state management solution or dependency injection framework you are using. So here we have a map. So we are, since it is have a type, so we have given this string which is first. So for that we have given the route name, so whatever the route is. Then on the value side we have assigned a map. So this is how we do it. Then put if absent works like if there is like the route is already exists in the lazy factories, then it will return that route. So if we go inside that, it will say that look up for the value of key or adds a new entry if it isn't there, and returns value associated with the key if there is one. If it finds a value, then it will return. If there is no value, then it will add a new entry inside that. So it will work like this. Whenever we call this put if absent, it will work like this. We are adding a key and assigning a value, and if there is already a value, then don't assign, just return it. So this is how it works, put if absent. Then whatever value it has returned, the map, inside that we are putting the our controller. Then for that controller we are assigning the factory. So this is for the multiple so that we can inject put multiple controllers on same route. Then we have get dot find method, where we are finding the existing controllers. So we have set the current route. If it is null, then no active route. Then we are doing the same things that in the controller. Earlier we are using the factories, now we are checking in the controllers. Then if controller there is a value, then return it, otherwise create an empty map. Then we are checking that if there is not a value, then do this, otherwise just simply return the existing controller for that route. Okay, so if there is no controller present on that route, then check for the factories. So in the factories we first get the map for that route, then from that map we are finding that controller, so it will return this thing. We are doing the same thing. So this will return the factory for that whatever we have assigned here. Then if factory is null, then you haven't put that route that controller in the controller store. So it is like you are calling get.find without putting the controller inside using the lazyPut or put. So in that situation this will be triggered. Then if there is a value, then call the factory. So it is like a calling a function. It is a function actually. So once we call the function, it will return a controller. Then we are putting that controller inside the controllers, because the object has been created, so it will be stored in the controllers. And whenever we put the factories, those factories will be put in the lazy factories. Then we have simply printed the log that controller has been created. Then we have called onInit also, that controller has been created, so it will trigger this init. So here we have extended the base controller, so it will trigger this thing, because everything is dependent on the base controller. So the type will be whatever we will find or put, that must extend the base controller. So here we can see that home controller is extending the base controller, so that will create a whatever object has been created, it will be stored inside a map. Then we will print the log, then we will call the onInit method. Then on that route, when the first frame has been drawn, then controllers onReady will be called. So this is how we can create our own controller. We don't need like GetX for small apps. If you want to create something like this, like some lightweight state management solution, so this will give you a basic understanding how you can create these things. Then on the dispose route, whenever from this dispose route, whenever replace, remove or pop will be called, this dispose route will be called. So this is important. This is all the headache we are going through just because to get this, because on the in the controller we can call APIs inside the constructor, but we cannot dispose it. Like we don't have any alternative for onDispose, so we must have this onDispose. So for that we have, whenever this dispose route will be called, first we will remove that route from the controller. Then we will have a map of all the controllers that have been injected on that route. So we will call we will iterate on all the values. then we will call onDispose on each controller. So each controller will be disposed, so it will trigger this thing. Then we will also remove the factory from this lazy factories also for that route. So this is the idea behind, like, this is how we can create our own lightweight state management and dependency injection solution. So this is all about dependency injection. We will see how we are going to use the state management inside this. So I think this is clear. You have to watch it twice or thrice to get better understanding of this. These are the not the things that you can understand in the first watch. So you have to revise it again and again and build up your understanding around it. So we have talked about our base controller, that these are the three things. We have also talked about abstract classes. You have to watch like class, which one it is, class inheritance, this video, to get the better understanding of all the classes, their modifiers like abstract, interface, sealed, base, final. I have talked about all these things inside that video. So we have created abstract, then we can extend it on any class. So to create a controller like GetX, get controller. So this is how we create. So whenever we extend it, and once we put it using controller store, then these functions will be called. And we will have the basic life cycle like onInit, onReady, onDispose. Then we have seen the controller route observer, that whenever we push something or pop something like any new route or previous route, these are the respective callbacks that will be triggered, and we will remove, or we will dispose the old route and set the current route. Then we have controller store, where we will store all the dependencies. Then we have controller view. So this is another important class. It is also abstract, so it extends stateless widget. So focus here, it extends stateless widget. So whenever we extend the controller view, so we will get the functionality of stateless widget also. So it has a build method, it has a constructor also. Just here we are defining our own getter for controller. So whatever controller we will pass here, that will be find from the controller store automatically. So instead of manually doing controller dot find, we can simply extend our screen to, like, instead of stateless, we can extend to controller view. Then we will have a controller getter to find it inside the build method. We will see how we can use these things. Then we have reactives, like we are creating our own custom value notifier. So we are extending from value notifier, so we will get all the functionality of value notifier, plus we have defined our own function on that, so that we don't have to write this again and again. We can simply call onChange on the value notifier, and we can simply return a widget from that, because it returns a widget. Then we have these type defs. We will talk about these things when we will see the API code. Then here the things are same like in the previous video. We have API client using the get connect. We have printer as a mixin. So mixin simply provides a like utility functions. We can, whenever we use it with the with keyword, then we get the direct access. We don't have to create the objects and anything. So we get this function from the printer directly here. We don't have to create the object of this printer, then call this, like that. Then we have, these are the same things that we have talked about in the previous video. So Then we have UI state. I have also talked about it in detail in the class inheritance video. So to get the idea about this, you must see that video. We will see the little more explanation of this UI state in this video also. Then inside that we have only one model. Then this is DI folder. Then we have a widgets folder to store all the common widgets like product card. We have a loader, we have a category grid. Then we have utility folder where we have printer, network manager, error helper and some constants. Then we have routes. So this is the folder structure that I follow. It is not, this folder is like this structure, like architecture pattern is like modular architecture pattern. It is not MVVM or MVC or clean architecture. So it is like mix of MVC and MVVM, because we are not defining globally anywhere all the models inside single folder, because whenever we create a big project, so if there is if we open that project after 2 months, we have to find like let's say we want to change inside that, and to find where it is located we have to go through like models. We have hundreds of models. In that list we have to find a model where is category item. Then similarly, if we create a controller folder here, then all the controllers will be stored inside that. So it is very difficult to find things around a large project. So for because of that I follow this folder structure. So I will also explain how these things are arranged inside modular structure. So here we have seen like these are the screens, static const, and this is like app route. I have explained it in the previous videos. You can watch that. Here there is one change, like here we are injecting the dependencies. So whenever we push a screen using named routes, it will check in the routes table. So this is the routes table actually. So in the main.dart we pass app routes, so it will go here and check if that route exists on this side. So it is a map. If you see here, it is a map of string and a function which returns a widget, a stateless widget. In this case you can return a widget also. So on this side these are the keys, on this side these are the functions that will be executed whenever we push or push a new screen using the named routes. So whenever we push a new screen, let's say we hit this button and it will install the app and launch the first screen. So this is the home screen. So it will first check if this home exists in this routes table. So here we see that there is no initial route or home screen defined. So it will check if there is a route which starts with the slash, forward slash. So here home is forward slash. So it will check for this value. If there is a value, there is a key, this key exists in the routes table here, then it will trigger this factory. Okay, so it will first put the home controller inside the controller store, so that we can find it using the controller store.find later in the home screen. So here we inject the dependencies, then on the home screen we have a find like this. We can controller store.find and it will find the home controller for us. So it will assign here. Then we can simply use this across this screen. So this is how we inject dependencies in the GetX also. So this structure is similar to the GetX. So we in the GetX we have get.lazyPut, get.find kind of things. So it is very simple and easy to understand. That is why I am using GetX as an example in this, like following the code structure of the GetX. So in the blog there are like different things in the GetX. These are the things that the idea is same in the this our own like lightweight library and the GetX. These are the same things. Then we have put the controller, then we have modules only. So modules, inside the modules, if you see the folder structure, so we have, I generally create these parent folders as a modules, like some things can be clubbed together, like inside this we can club all these things inside the auth, because these are the things that are related to authentication: login, sign up, forget password, change password, two-factor authentication. So these are the folders that can be clubbed inside the auth folder. Then on the home screen we don't have any other module inside the home, so only single screen. If we have like bottom navigation bar, then we can have home screen, we can have a reels screen, we can have a settings icon here. So inside this, then we will have subfolders for the home, for the setting, for the reels, or we can have the navigation as a home screen. So whenever we have a bottom navigation, so instead of creating home, we will create like this. First we will create a dashboard, so it will contain multiple screens. So we have a dashboard, then we will have our UI folder, we can also have a repo folder for storing repos, and we can have a models folder. So all the things that will be used inside the dashboard, all the models will go here. A single repository for the dashboard will go here. Inside the UI, then we will create a home folder, then we can have a settings folder, and if settings screen has multiple sub modules, then this folder won't be created here. Instead this will go here, simply like this. Settings will be a separate module. So if you have only single screen and there isn't any like sub modules inside those screens, then only we can create here. And if any screen has multiple sub modules, then better keep it as a separate module here, because nested modules are not good. So because here we will have a single repository for all these subfolders, and we have, if we have like settings, inside the settings we have accounts, we have saved reels, history kind of things. So a lot of APIs will be there. So in the single API, it is not recommended to have a lot of APIs in single repository. So if module is very large, then better keep it as a separate module, sub module as a separate module. So this is the idea, and when that happens, we can simply here have, instead of this, we can have here our screen directly, like inside the dashboard we can have dashboard screen, then we can have dashboard controller as well, dashboard controller. So inside the dashboard we will have a basic scaffold, stls dashboard screen, like this. Then we have a scaffold, and here we will define a bottom navigation and the body for the like we can have a body. Inside that we can use indexed stack, and here we can have bottom navigation bar where we can pass bottom navigation bar. Inside that we can have so like this. So we can also create a here class dashboard controller. Then we will have a variable for storing the current index. We can make it like observable later. Just to explain the things, I am creating this as a non-observable. So inside the stack we have index. Here we can use controller view, then we can pass here our dashboard controller like this. And so dashboard container is not extending. Let's extend base controller, then it will be good to go. So here we can directly access the controller getter from the controller view. We don't have to create any put, like in the home screen I have shown you, like we were finding it manually. Where it is, we are finding it manually, controller.find. So instead of that we can use this approach. We can simply extend it to a controller view. In the GetX there is like get view. Similarly here we have created controller view. You will find this same code inside the GetX in getView class. So here we have defined our custom getter to find the controller. So we have access to the controller, we have access to the index, then we can pass the children. Let's add some placeholders for the, so this is for the home screen, then we can pass it for the reels, for the settings. Then here we can have 3 icons, and on click we can assign the current value to this index, and this will be rebuild. Whatever index is selected here, that respective widget will be displayed on the screen. So this is the dashboard screen. Now these things we will create separately, like we can pass here home screen, then we can have home as a folder here. So this will be the dashboard. So whenever we have both these folders, there is a basic understanding that dashboard will contain the navigation of the dashboard, and the respective bottom menus will have different modules. So this is how we can arrange our code. So we can have, there won't be any models used for the dashboard, so we don't need this. We don't need also this, because we don't have any APIs on the dashboard screen. If we are going to use this structure, like we can create separate folders for each submodule, because this submodule will have also submodules, so better keep it as a separate. So whenever there is, like inside this, you see there is no submodule. These are the only things that are available inside the repo. If there is some case where we need something inside, some more modules inside this module, then better keep this module as a here on inside this folder. So this is the idea, like this dashboard inside, and here settings. Inside that we can have multiple modules, but this screen will be shown from here on the bottom menu. So docs have also came from for the class on time, because it So this is clear. Then we have, like in this case, we have home screen where we have models also, we have API also. For that we have created a home repo. Inside this we have two APIs, one for the category, one for the products. So this is the standard structure. Now let's proceed to the list. So inside the product, let's say we can have, inside this application we can have search functionality, we can have view all product functionality, we can have sorting, filtering, we can have detail screen also. So all these things are related to the product. So we can create a parent module as a product. So whenever you see this folder structure, and if I ask you where is the product list, you will say that it is inside the product. And if I say that where is the product detail screen, you will say that it is inside the product also. You won't go inside the home or auth. So this is how you can club multiple screens inside a single folder. So if you go inside this, you will find the list and detail screen. And let's say we have a search also, search product. So we can simply add a new module here, search. So whenever I say that where is the search product, so you will say inside the product folder, because search product, instead of writing like this, search product. Okay, then if we don't follow this structure, so this will be the folder structure that will be, then we have product list, then we will have product detail. So you will see that we have multiple things with the product, like product detail, product place, search product. So and we can have here more folders related to products. So instead of creating separate these are as a separate, we can club all these inside the product. So simply remove product from all these and rest add here, search product, list product, detail product, like this. Let's remove this. So this is how I arrange my code. So whenever any new developer works on my project, so it is very easy to navigate across the project, like throughout the project you can easily find the models for that screen. Let's say I am working on the list, so I will go nearest models folder. So inside that I will create a models folder here, models. So if there is a list and we are using some models inside this, so that will be present inside this. We don't have to go through these or these or these or those, no such things. Here we have a common models folder. Here inside this we can have two things. We have common models, we can have common controllers also. Like some controllers are needed for managing data that will be used across screens, like that will be like related to profile or login data kind of things, or balance, wallet balance kind of things. So that will be used across screens. So we can create some common controllers here that will be marked as permanent. So in this controller store, like I haven't created a permanent kind of things here. In the GetX you will find get.lazyPut, then you have an optional parameter Phoenix for the lazyPut and permanent for the put function. If you pass permanent true flag inside the permanent, then whenever that route is closed, the controller won't be destroyed. So controller, it will be like singleton. So like we have created the API, so it is singleton. So similarly we can use singleton also, we can use GetX controller also for making the singletons. So dependency injection also helps in maintaining the object state, like whether we want a single object for single route, or whether we want new object every time, or whether we want single object on each route, or whether we want single object across the app. So get dependency injection also helps in managing that. So inside that, whatever items, models will be used inside this these controllers, like user data, wallet balance, we can put these things here, and the common controllers will go here. So for that purpose I have created a separate folder. So in the widgets, all the common widgets will go inside the widgets folder. Then inside the modules, we don't have, like, we cannot like mix dependencies, like creating some controller here and using that controller here. We cannot do that. So because that is not a recommended way to manage the dependencies. So you have to follow these rules if you are using this architecture pattern, and if you are going for the MVVM or clean architecture, there are like different rules for different architectures. There is common thing, separation of concern, single responsibility. There are like 5 principles, solid principles in those things, like separation of concerns, single responsibility of each class. So single class cannot do multiple things, kind of things. So we will talk about all these things in coming videos. So I think this video is going to be very long, or should I keep it in 2 parts? Let's see some more things, then we will end it. We'll make it around 1 hour. So we have understood the dependency injection. Let's see the standard API example that I have also talked in the previous example. In this example, this will be standard folder structure. If you are going to follow this structure, I use this, you can also use this. If you are working on some personal projects, and if you are working in the company, and companies also have different policies for the architectures, for coding patterns, so you have to follow their structure, cannot follow this one. If they allow, you can do this. So I think this is from my perspective, I find it more useful, because this is not a standard, something standard that is available on the internet, or anyone like Google or Microsoft, someone is like recommending. This structure I have developed it, like I have 7 years of experience. During those years I have understood some things. I have faced a lot of challenges in finding the code, navigating through the folders, finding the screens, models, everything. So I came up with this solution. So now on I use this architecture pattern. I name is like you can call it modular structure, because everything is like main focus on this in this architecture pattern is the modules, how you arrange your code. Architecture patterns are all about arranging the code, managing the concerns, separations, dependency injections. So this is the way how you can arrange your code inside modules. So all the things are modular, so that is why it is modular structure. It is like mix of MVC and MVVM. It is not purely MVVM or MVC with the repository pattern. So we will I will make separate videos on each architecture pattern, what is MVC, what is MVVM, what is clean architecture. So you will have all the understanding about all the architectures, popular architectures, so that whenever any interviewer asks you about the MVVM, you can say with the confidence that yes, I know that architecture, I have worked with that architecture. So some confidence whenever some question is asked in the interviews, because confidence is all that matters whenever you answer something. In the I remember that in my first company where I the first company that I joined, that interview was absolutely wrong. I have answered most of the questions incorrect, given wrong answers, but my confidence was very high. So even interviewer was confused that whether I am correct or he is correct. So that confidence, it doesn't matter whether you are right or wrong, but realize that mistake and learn. So that is how I improved myself throughout these years. Now I am teaching all these things. So my suggestion will be, have a basic understanding of all these concepts, and in the interview, if you know something, answer with the confidence, and if you don't know any answer of that particular question, just simply say that I don't know, or I haven't used that, I don't have much knowledge. These are the appropriate answers that you can give. I won't recommend that bluff. You cannot bluff inside the interview, but things happens. These things can happen with anyone. So if you are little confused with your answer, that you know but you are not sure, so just say that. Let's say interviewer asks what is stateless widget. So just, if you don't know much about it, just say that whatever you know, stateless, there are two kind of widgets inside the Flutter. One is stateless and one is stateful. And if you don't know much about stateful, then just say that in the stateful widget there is a state, but I haven't used it, so I don't know much about it. That's the perfect appropriate answer that you can give. So interviewer have a basic idea that you have some knowledge but not all the understanding about that. So instead of getting -1, you will get 0.5 plus. So it is just stateful and stateless. These should be known. So it is about the complex concept. If you get stuck in somewhere, there are questions like what is stream builder, or how many types of streams are there, or how many types of keys are there. These are the things that where you can answer like this, that these are some concepts that are little bit on the intermediate or advanced side. So if you are giving interview for 1 year experience or fresher, you can use this answer for these things. Like if you say that someone asks you what is what are the keys inside in the Flutter, so you can, if you don't know much about it, you can simply say that there are keys like global keys, local keys, but I haven't used these, so I don't know much about this, but I definitely learn about this. So this is the appropriate answer. So that's how you can answer whenever you get stuck. Don't bluff. So I did, because at that time I I never worked in the company before that, so that was the first company. I had given interviews, 1 or 2 interviews. So my DSA was very strong, so I got the confidence from the DSA that yes, my logic is very strong, my DSA is very strong, so whatever I tell, that will be the correct. So that is why I answered around 40% questions wrong, but I got selected just because of the confidence. So but I left that company after 5 months, after realizing that they don't have that kind of company policies, you can say, or that company was not very appropriate, or you can say that you are not very valued, you don't get that value that you should have gotten having that much experience. So things happens, you switch for money, you switch for due to company policies, lot of reasons are there. So I think let's see this screen code also, then we can end this video. In the next video we will discuss more about these things. We will discuss more about the folder structure, we will discuss more about APIs, state management. After this video I think I can start with some let's have a next video on the interview series. So I will prepare around 10 to 20 questions for the basic to intermediate interview, so that you can prepare for the interviews also along with learning the concepts. So here you have also already seen that we are injecting the dependencies from here, from the route table. This is the factory for creating the screen. Here we are simply calling controller.controller.find, then we have home controller, and inside the home controller if we see we have a base controller, then we have a repository. So these are the things are like were available in the previous video also, just copied pasted. So we can skip these things in this. So here we have, because we are extending from the base controller, I have explained all the things that we will get the callback whenever first frame will be drawn for this screen. So we are calling both the APIs independently, they will run in the parallel because we are not adding await before that. So whenever we get the response from the API, we are simply storing that state inside the category list state, and same is for the product list state. Then these are the value notifiers. If we go inside this is the class which extends from the value notifier. So both these variables will be the value notifiers, so we are disposing them. So here these are the things, I think these are clear. Then here we have a refresh indicator like this. Let's add it here somewhere. Then you remember we have a printer here also in the API client, where it is, whenever request modifier and response modifier we are printing whenever the app is in the debug mode. So if we refresh it, you will see these network logs in the logcat. So this is the API response you get. So this is the request, this is the response URL, this is the response body, and so this is the for the product. And on the refresh, I am only refreshing the products because categories are loaded once. We can also we can convert it in the function body, then we can call both the APIs from here. Then we have a list view. On the top we have categories title here, then we have a divider, this one, then we have this onChange. I was telling you that on the value notifiers we have created our own class just to get this onChange. So instead of adding a ValueListenableBuilder, then passing that value inside this, then passing a function, we can simply call, because this is Rx type which is our class, then we can call onChange directly from on this. Then inside that we have a builder, inside that we will get whatever value it is storing. So it is storing a UI state, it is storing a UI state, so it is returning the UI state. So in the previous video I have talked about UI state and when function. Here we have defined a when function. In the next video, I think I will explain more about these things, because there are a lot of people who these concepts are not clear to them. So we'll make a video on these things. So on change, whenever the value of this will be changed, this will be triggered, we will get the value on that value because it is a state. We are calling when function. Inside when we have 4 functions. Whenever we get the success, we pass category grid widget, the whole thing, this one. If there is an error, we simply are showing the error. If there is a loading, then we are showing the custom loader. If the initial state is none, so we are showing the size box. Then we have added a height like a space here. Then we have a product title. Then we have a divider. Then same thing is for the product list. Here we have, instead of horizontal list, we have vertical list. So here on success, we are rendering the product list, and whatever data we get from the success, we can pass this inside this, and here we have list of products. Then we are using the grid. I have also talked about this in the widgets folder, widgets video. So here we are simply building like all the items. We have a common product card where we have defined these things. You can check this code on the GitHub. You can check this branch custom state management for this video. So all the code which is shown in this example will be available on the GitHub. You can find my repository on the GitHub. I will add links in the description. So this is the effect you can achieve when you use UI state without adding a lot of variables for loading. If let me show you one thing. Let's call both the APIs. Get category list, and we need to return a future. So returning from this. Or one more concept, if we have 2 APIs and want to hide this one only when we get the response from both the APIs, then we have a future dot wait. Then we can pass both the things here inside the list, and we can return a combined future from this. So okay, so whenever we get the response from both the APIs, then only this refresh indicator will be hidden. So now if we run this, let it load. Then if we see both the loaders, let's add some delay. This is not loading. Then add a future dot delay duration dot seconds, 2 seconds delay for showing the loader. Control C. Let's add in only one. Okay. Then you see we have added delay in the products. So the loader, this loader is still running, and this loader has gone. So if you see the code, so we have 2 widgets, one is for the category, one is for the product. So we have 2 variables. Each variable is managing state of single API. So whether it is error, loading or success, every information is available inside this single variable only, instead of creating 3 variables for one API, like loading, is error, is success kind of things. Instead of that, we can simply have one variable to hold all the possible states of single API. So here whenever state of this variable changes, we simply say that if it is success, then display this category grid, otherwise show error, otherwise show loading. And if we have 3 variables for each API, then we have total 6 variables, and we will add a if else here, like if it is loading then show loader, if it is error then show error, if it is success then show this. Then we will do same thing for this also. So that code will not be very pretty much like readable. It won't be, it will be a lot complex just for 2 APIs. And suppose there are a lot of different widgets. Here we simply have only 2 APIs. On the dashboard or home page, generally in the big apps we have a lot of sections. Like on the top we have some banners, then we have some popular items, then we have some categories, then we have some recently viewed or product list, then on the bottom we have some recommendations kind of things. So a lot of APIs are there, and in this, with this code also you can show skeleton like shimmer effect animation, like shimmer loading animation. So you can manage the loading for each API individually, independently. So you don't have to create 3 variables for each API. So this is the idea behind using UI state. This is the idea, like the reason behind using this folder structure. So I have explained, I think, most of the things. Only thing that remained I wanted to discuss, the type def, where it is, where it is, okay, reactives. So I wanted to discuss the type def and more about UI state, so that you can get more understanding of this. We will talk about these things in the next video. Will be next video will be might be very short. Okay, so stay tuned for the next video. Thanks for watching. Keep practicing, and if you are new to this channel, do subscribe so that I get more motivation to create like record more videos, so that I can share more, you can learn more. And also like the video and share with your friends, only to those who want to learn Flutter. Okay, thanks for watching. Stay tuned.